Hi everyone, welcome to this data annotation course. I'm your instructor, and today we're diving into the first part of the material. Hope you're ready, let's get started.
Now let's start with Chapter 3, which is about image data annotation. In this chapter, we will cover several key points. First, the introduction to image data annotation. Then, we'll discuss the key point marking method, followed by the marking box marking method. After that, we'll focus on the image area labeling method. We'll also have a summary of this chapter, as well as assignments and exercises. Generally, image region pertains to the technique and process of dividing an image into characteristic regions and extracting the target of interest. Region annotation is a crucial step from image processing to image analysis and is a fundamental computer vision technique. Only based on region annotation can we conduct feature extraction and parameter measurement of targets, enabling higher-level image analysis and understanding. Thus, studying image region annotation methods is of great significance. From the perspective of the opening and closing of the local area, image area annotation can be classified into open area annotation and closed area annotation. Open area labeling commonly involves line labeling. Closed area labeling usually includes curve labeling and polygon labeling. Interactive intelligent image segmentation is also an important form of image region annotation. It aims to solve two major issues. Automatic segmentation is ineffective for images with multiple targets or complex backgrounds, and manual annotation is extremely time-consuming with inaccurate and irreducible results. Interactive intelligent image segmentation first recognizes the image through a segmentation and labeling algorithm for intelligent machine-based segmentation, and then manual trimming and screening are carried out, significantly improving production efficiency, reducing labor costs, and minimizing manual errors. Therefore, it has great practical value. Next, we'll introduce polygon annotation and interactive intelligent image segmentation in terms of suitable scenarios, annotation tools, annotation schemes, and case studies. Image area annotation is generally categorized into three types. The first one is line annotation. It is often utilized for lane line annotation in autonomous driving applications, mainly for the road identification of self-driving vehicles. An annotation example can be seen in the figure. The second type is polygon labeling. It is more accurate as it can avoid a lot of white space and visual model deviation. It is commonly used to label street pictures, people, animals, and human body parts. Labeling examples are presented in the figure. The third type is interactive intelligent annotation. It is an improved region annotation method based on manual and automatic region annotation. So, interactive intelligent image segmentation can be applied to face, human body, and autonomous driving, etc. An annotation example is shown in the figure. In this section, we'll take the sample region labeling tool of Datatang as an example. Image area annotation tools include both conventional polygon annotation tools and interactive intelligent image segmentation tools. For the polygon labeling tool, its page is divided into four main areas: the drawing selection area, which displays the picture and specific labeling; the tool area, which shows all the necessary zoom in and zoom out tools during the labeling process; the label area, which shows the label content by distinguishing layers; and the statistics area, which is a list for statistical labeling of graphics. The labeling interface is shown in the figure. For the polygon annotation tool, the functions of its toolbar are presented in the following table. For the interactive intelligent image segmentation tool, its interface layout consists of three parts: the main view, which displays the picture and specific labeling; the toolbar, which shows all the necessary zoom in and zoom out tools during the labeling process; and the label bar, which shows the labeling content by distinguishing layers. The labeling interface is shown in the figure. The project aims to label the human body by contouring its parts and then selecting the corresponding labels. The project serves as data support for human segmentation applications in image processing. The requirements are to contour various parts of the human body, a total of 19 labels, mainly the facial features and hair, and then select the appropriate labels. The labeling process is as follows. First, determine whether the data is valid. This project only requires labeling a single picture, and other situations like large area obscuration or characters without hair need to be invalidated. Second, according to the principle of layer coverage, mark polygonal dots along the outer edge of the marked object's contour, using multi-line segments to ensure the roundness of the polygon as much as possible. Third, select the label name, such as left eye, right eye, nose, hair, etc. The marking effect is shown in the figure. The acceptance criteria are that the polygon labeling box should be rounded as a whole and fit as closely as possible. Special attention should be paid to fine labeling the hair part. The chart labeling pass rate should reach 95%, that is, all the content in a chart must be accurately marked to be considered qualified. If there is any error in a chart, it is recorded as a mistake. The project markup output includes the original image, JSON, and the effect image. There are several difficulties in labeling. Firstly, annotation is very time-consuming. It can take up to 40 seconds to annotate a single object in an image. If there are 10 objects in a picture, it will take about 7 minutes to annotate the whole picture. Secondly, there is no uniformity in the form of annotation. Depending on the objects to be annotated, there are various shapes of annotation boxes, including polygons, circles, ellipses, and even irregular shapes. Finally, there are relatively few intelligent tools for image area annotation, and more manual annotation is required.